Hello guys, welcome to this channel, and today we are going to learn about GPU, HSA and QPU and also CPU. Now let's start this lesson. Now before we start, let me introduce myself. Myself is Hisham. I am a college student, and today we are going to learn about these topics that I just said about. And there is a bit of background noise from the fan, and if it's a bit disturbing, then you can comment how to improve it and what are the improvements that I have to make in these videos, because I'm not very familiar to making videos. So yeah, let's start learning. So GPU, graphics processing unit. GPU, a GPU is like a specialized processor dedicated to handling graphics and visual tasks such as rendering images and videos. Think of it as an artist in a team focused on making things look good. So GPU is basically there to make things look good in order to increase graphics. It's in the name, graphics processing unit. And the advantages are great for graphics. GPUs or graphics processing units are designed to handle images, videos, animations, so they make games, videos and graphics software run smoothly. Parallel processing power. A graphics processing unit can handle thousands of simple tasks at once, making it ideal for things like rendering 3D images or handling AI computations. Disadvantages. Now talking about the disadvantages, it's not built for general tasks. So GPUs aren't optimized for general computing, so they aren't usually efficient for non-graphical tasks. More power consumption. They are not efficient, so you know what it means. It does take a lot of power. And APU, accelerated processing unit. APU combines both CPU and GPU on a single chip, which means it can handle both general tasks and graphics in one place. It's like having a multitasker who can handle both basic tasks and artistic tasks. It's like a full stack developer. Like front end and back end are two, CPU and GPU, but for a full stack developer, he should know both front end and back end. So that's in computer terms. Now advantages: space and cost efficient. So since CPU and GPU are combined, APUs are more compact and cheaper to produce, which lowers the cost of devices. Good for everyday use. For basic tasks and moderate graphic needs like casual gaming or streaming, an APU performs well without needing a separate GPU. Disadvantages: limited performance for high-end graphics. APU aren't as powerful as standalone GPUs for demanding graphic tasks, so high-end gaming and professional video editing might be slow. Shared resources. Now, since CPU and GPU share memory and other resources, APU may be struggling when handling several demanding tasks at once. HSA, heterogeneous system architecture. HSA is an architecture that enables the CPU and GPU to work together more efficiently. Think of it as a communication system that lets different parts of the computer collaborate seamlessly. So advantages: efficient task sharing, HSA allows CPU and GPU to share tasks more intelligently and improving performance for applications that use both general and graphical computing. Optimized for modern application, HSA is ideal for programs that need both processing power and graphics, such as games or multimedia applications, such as applications, as it reduces the time needed to move data between CPU and GPU. Efficient task sharing, HSA allows CPU and GPU to share tasks more intelligently, improving performance for applications that use both general and graphical computing. Optimized for modern applications, HSA is ideal for programs that need both processing power and graphics, such as games or multimedia applications, as it reduces the time needed to move data between CPU and GPU. Now let's talk about disadvantages. Software dependency. For HSA to be effective, software must be designed to take advantage of it. If the software isn't optimized for HSA, the performance boost will be limited. Still emerging, not all systems or applications support HSA fully, so it is still limited. Now let's talk about QPU, Quantum Processing Unit. It uses quantum mechanics to handle calculations. It is like a genius mathematician who can solve incredibly complex problems that regular computers struggle with. Advantages: unmatched power for certain tasks. Quantum processors are highly powerful for specialized problems like complex simulations, cryptography, and certain AI tasks. Efficient for complex computations and disadvantages. It is still experimental and expensive. Quantum processors are in early age of development, so they are very costly and limited in availability. Not useful for everyday computing. For now, QPU are suitable for regular computing as they are meant for highly specialized and complex problems. So, did we cover CPU? We covered GPU, which is specialized for graphics and parallel tasks, but not limited to general use. APU combines CPU and GPU, ideal for everyday tasks and modern graphics, but not powerful enough for high-end graphics. HSA architecture that lets CPU and GPU collaborate efficiently, improving performance in mixed-use applications, though reliant on software support. And then there is QPU, quantum processor, for solving extremely complex problems, still experimental and limited to specialized tasks. And then we have to talk about CPU. It is the main processor in most computers, and it is advantages is versatile and powerful. CPU can handle wide variety of tasks. It can handle simple calculation to complex algorithms, making it ideal for general purpose computing. Good for single-threaded tasks. CPU excel at tasks that require a lot of logical processing in the linear step-by-step fashion, such as running a core application of operating system. Central coordinator, a coordinator manages direct other part of the computer, such as memory, storage, input, output, to keep everything running smoothly. Disadvantages: limited for graphics and parallel processing. They aren't optimized for graphical or highly parallel tasks like GPU are. And that's all. Now subscribe to the channel and like the video if you like it. And yeah, goodbye.